Welcome to Trigonometry. This is video lecture for section 4.4, the other trigonometric functions. So in this video, we're going to be graphing or figuring out how to graph tangent of x, cotangent of x, secant of x, and cosecant of x. In the previous video, we worked on sine and cosine only. So now we're going to focus on tangent. And before we get going, let's just recall what the basic graph for tangent of x looks like before we start playing around and changing the period and stretching it and all that good stuff. X-axis, y-axis. And then remember we investigated last time, tangent's graph has vertical asymptotes at negative pi over 2 and pi over 2. And the graph repeats every pi. And instead of 5 key points, you're going to graph 5 things. 2 of the things being the asymptotes at pi over 2, negative pi over 2. And then we have 2 key points, pi over 4, 1, and then pi over 4, negative 1. So tangent's graph goes through 0, 0, pi over 4, 1, negative pi over 4, negative 1, and then it comes really close, it hugs those asymptotes at pi over 2, negative pi over 2. And this is one complete period. So notice from negative pi over 2 to pi over 2 is pi. So that's one period. That's different than sine and cosine. Remember, sine and cosine's period is 2 pi. That's how long it takes to complete a cycle, a complete cycle of the graph. Tangent is half the time. Okay, so now let's see here. We're going to be taking our original tangent function and then manipulating it, applying some transformations. So just like before, if there's a coefficient on x, which we call b, that affects the period. So to get the new period, you're going to take pi and divide it by b. And then similarly, we can shift the graph horizontally, which we call a phase shift. So to find the phase shift, you take c and divide it by b. That's the same as before. And then the other thing is, if you want to figure out where the successive vertical asymptotes are for the graph, then you can solve the inequality. Negative pi over 2 is less than bx minus c is less than pi over 2. Honestly, I don't usually do that because I just use the 5 key features of the graph. I remember what the tangent graph looks like, and then I go from there, okay? If you like this inequality though, you were taught this way before maybe, that's fine, but I'll show you how I do it. I don't use it. Okay, so here we go. Keep in mind the graphs that we're looking at today, tangent, cotangent, secant, cosecant. These graphs do not have amplitude. They're not bounded, all right? So example 1, find the period, the phase shift, and sketch the graph of the equation. No problem. So the period is equal to pi divided by b. Be careful. And what is b equal to here? Can you see? b is 1/2. So then, excuse me, the new period is going to be pi divided by 1/2, which is equal to 2 pi. Now the step tells us how far apart each of those key points or key features are. So we still have to find the step. The step is always the period divided by 4 for all of our trig graphs, sine, cosine, tangent, everybody. Period divided by 4. So 2 pi over 4 is going to be pi over 2. There's no phase shift. Notice I don't have anything added or subtracted inside the parentheses with x, right, with the argument. So I'm just going to state that so they know we thought about it. No phase shift. All right, great. Now it's time to draw our graph. So here's how I like to start. We know the tangent graph goes through 0, 0, so start there. Then you count 2 steps to the right for one asymptote, 2 steps to the left for the other. X, Y, here we go. So the graph is going to go through 0, 0. We go 2 steps to the right. So pi over 2 is 1 step. Pi is the second step. Bam, there's a vertical asymptote right there. And then we go 2 steps to the left, and there's the other asymptote. So here's negative pi over 2, and here's negative pi, and my other asymptote is right there. And then the graph, now I'm going to plot the points on the graph. It goes through 0, 0. And then the other 2 points that you should include are a quarter of the way along. So look back at the parent graph. I'm going to go back up here. See how a quarter of the way, halfway between the asymptote and 0, 0, we plotted pi over 4, 1. And then on the other side, negative pi over 4, negative 1. Well, since the period's been changed, we're going to have this happen at pi over 2 and negative pi over 2. So there's 1, there's negative 1, and I'm going to plot those 2 points as well. So pi over 2, 1, negative pi over 2, negative 1, and then you draw the graph the same way. Okay, make sure you put arrows. Now, it's good practice to always get in the habit of writing out the domain and range. Okay, now this can be a little bit tricky, but I'll walk you through it. So, the domain. The domain is definitely not all real numbers because everywhere there is a vertical asymptote, we have to remove that value from the domain. The graph is undefined there. Remember, that's when we first looked at asymptotes because we know since tangent is equal to sine divided by cosine, everywhere cosine is 0, the graph is undefined. So, the way we write it out is we say the domain is all x's such that x cannot equal, and then here's usually the best way to go about it. Give the equation of the first positive vertical asymptote. So the first positive vertical asymptote that I see is at x equals pi. So that means the domain is all x's such that x cannot equal pi. Now, am I going to sit here and list every single vertical asymptote? No, I couldn't do it. I would die before I would get done because there's infinitely many. So what you do is you just give a rule that somebody could follow so they could figure out where all the vertical asymptotes are. So what's the rule? You're going to get another vertical asymptote every 2 pi because that's the period for this graph. So I could add 2 pi, add another 2 pi, add another 2 pi, or alternatively, I could keep subtracting 2 pi. Keep subtracting forever and forever. So they're 2 pi spaced apart. So the way we say that is x cannot equal pi plus 2 pi k, where k is an integer. And that's basically how you give a rule for all of the domain restrictions or where all of the vertical asymptotes are. Now, as far as the range, what are all the y values that the graph can take on? Notice it goes down forever on the left, up forever on the right. So the range is all real numbers, negative infinity to infinity. Or you could write all real numbers. It's up to you. Okay, the domain is tricky. It's going to take a little bit of practice, but you guys will get there. Okay, let us look at the next example here. Y equals 1/3 tangent 2x minus pi over 4. How spicy. Oh my goodness. Okay. Let us figure out what's going on. First things first, I notice there's this 1/3 in the front. That's a vertical compression. Why do I say compression instead of stretch? Because it's a number. 1/3 is smaller than 1. So it's actually going to look like someone like sat and smashed the graph. Okay, how is that going to affect things? Well, remember how we plot those points at 1 and negative 1? Instead, we're just going to go to 1/3 and negative 1/3. Okay, now let's notice some other important features here. B is 2, so that means the new period is going to be pi divided by 2 in this case. So the step is the period divided by 4. Anytime your period involves a fraction, so pi over 2, instead of writing divided by 4, think times 1/4. Same thing, just easier to compute. And so the step is pi over 8. Okay, good. And then we need the phase shift. Remember, the phase shift is equal to C divided by B. And you don't include the negative, right? So it's going to be pi over 4 over 2, which is going to be pi over 8. And since that's positive, just remind yourself phase shift positive means we shift to the right. Okay, so I think we're ready to get going. It may not feel like it, but we certainly are. So here we go. Here's the y-axis. Hold on, it's a little crooked. Let's straighten it out. Come on, y-axis, cooperate. Good. And here's the x-axis. Now, normally we start with 0, 0, right? But phase shift tells us we're going pi over 8 to the right. Pi over 8. So that's basically our new 0, 0. Boop, there. Count 2 steps to the right, bam, vertical asymptote. 2 steps to the left from there, another vertical asymptote. So here we go. Good thing the step is pi over 8. So if I add another pi over 8, that's 2 pi over 8, which is pi over 4. Add another pi over 8, now we are at 3 pi over 8. There's a vertical asymptote. Okay, back to the middle, back to pi over 8. Count 2 steps to the left, there's our next vertical asymptote. So 1 step to the left, we're at 0. 1 more step to the left, now we're at negative pi over 8. And another vertical asymptote. Good? Okay, so I've got those 2 down, and I have the point pi over 8, 0, so I just need those 2 more points a quarter of the way through, but remember we have that vertical compression. So I'm just going to label my y-axis and say, hey everyone, this is 1/3, and this is negative 1/3. And that's really all you need to do. So pi over 4 1/3, and then 0, negative 1/3 is where the other point happens. And here's our tangent graph. It will never, never cross those vertical asymptotes. So make sure you show it approaching, but not touching or crossing or doing anything crazy. Okay, good. Now let's write out the domain. So the domain is going to be all x is such that x cannot equal, where is the first positive vertical asymptote? I see it right here at 3 pi over 8. So x cannot equal 3 pi over 8 plus, how long does it take to get another vertical asymptote? How long is that period? Go back, you should have found it. The period's pi over 2. So x cannot equal 3 pi over 8 plus pi over 2k. You want to learn a cool abbreviation? Instead of writing k as an integer, you could write k is an element of, and then you write this fancy math script z. That means the set of integers. If you hate that, that's fine. You can write in words k is an integer, but I'm just looking out, trying to find you some abbreviations. Okay, domain, we got. Range is always easy. It's the same. All real numbers. If you like writing and you want to write in words, all real numbers, go for it, okay? I love abbreviations. I think they're cool. Okay, now time for cotangent. So cotangent's graph is a wee bit different. Do you remember what the basic graph looks like? If not, I'll remind you right now. We'll just sketch a little baby one right here in the corner. Period's the same. It's pi. Step, all of that is the same. The vertical asymptotes are in different places. That should make sense because cotangent is cosine of theta divided by sine. So it's going to have vertical asymptotes wherever sine is 0, not cosine, right? Okay, cotangent's graph starts off, bam, vertical asymptote at the y-axis. And then when you're counting, okay, so you have pi over 4, pi over 2, then 3 pi over 4, pi. It's not split over the y-axis. Then we have another vertical asymptote here at pi. It's going to go through pi over 2, 0, but then it's decreasing. So at pi over 4, we have positive 1. At 3 pi over 4, we have negative 1. So it looks like this. So cotangent's graph is decreasing, the basic one. Tangent's graph is increasing. Okay, let's look back at the original for you to see and compare. So here's cotangent. Now look at tangent's original. You see how it goes through 0, 0, and the vertical asymptotes are split over the y-axis? Cotangent's different. Cotangent starts off with a vertical asymptote at the y-axis. Count 2 steps, bam, there's 0. 2 more steps, there's your other vertical asymptote. And then just flip the points because it's decreasing, okay? Alternatively, you can solve this inequality. 0 is less than bx minus c is less than pi. Okay, here we go. You should be fine. Find the period, phase shift, and then sketch the graph of the equation. So first one, y equals 4 cotangent to x. First things first, I noticed this 4. What does that mean? That's a vertical stretch. Why did I say stretch this time instead of compression? Because 4 is bigger than 1. So it's going to make the graph taller. It's going to look skinnier, like someone stretched it like a piece of taffy. Okay, the period. The period is 2 pi. No, excuse me, it's pi. Oh my goodness. Pi divided by b. b is 2. So the period's pi over 2. What about the step? The step is the period divided by 4. I'm going to think of it times 1/4 instead. So the step is pi over 8. And there is no phase shift, none of that going on. All right, so it's time to graph. There really wasn't much going on with this one. How nice and relaxing. Savor it. So here's the y-axis. I don't draw so much of the negative x values for cotangent because of the way the basic graph is, right? X-axis. Now, this is optional, but I do like to draw a little bit extra dashed lines above and below the y-axis just to remind me that there's an asymptote there. Otherwise, you might think you forgot it or get confused. Now, the step is pi over 8, so I'm going to count 2 steps, 1 pi over 8. 2 pi over 8 is pi over 4. That's where the 0 happens. And then 2 more steps to the vertical asymptote. So that was 2 pi over 8. Now we're at 3 pi over 8. 4 pi over 8, people, that's pi over 2. Okay? Always got to reduce your fractions. Looking good, looking good. Now we've got that vertical stretch. So you're just going to label your y-axis 4, -4, instead of 1 and -1. And then plot those points a quarter of the way through. Oh no, we drew over 3 pi over 8. That's okay. And here's the graph. Okay, beautiful. Now, let's talk about how to write out the domain. The domain is going to be all x's such that x does not equal. Now notice here we have a vertical asymptote at x equals 0, x equals pi over 2. The next one would be at x equals pi. So you could say x cannot equal 0 plus, what was the period? It's pi over 2k, right? But 0 plus anything is just itself. So you don't have to put the 0 plus. You could just write x doesn't equal pi over 2k, where k is an integer. And then the range is also going to be all real numbers. Okay. Good. One more of these. Do you like cotangent or tangent better? I think cotangent's easier because the first asymptote is right there on the y-axis, but for some reason I like the look of tangent better because it's symmetric. I don't know. Tell me your opinion later. So we've got here 4 cotangent 1/3 x minus pi over 6. Again, another vertical stretch. I'm just going to write it off to the side. So we've got vertical stretch of 4. What's the new period? So the period is going to be pi divided by, can you see what the value of b is here? B is 1/3. So if you have pi divided by 1/3, that becomes 3 pi. That's the period. Okay, lovely. The step is the period divided by 4. So the step is going to be 3 pi over 4. Ooh, we have a phase shift. This is getting fancy. So phase shift is c divided by b. Pi over 6 divided by 1/3. So that's pi over 6 times 3 over 1. 3 pi over 6 is pi over 2 to the right. Okay. I think it's time to get rolling. If you want to remind yourself, notice the step is 3 pi over 4 and the phase shift is pi over 2. Pi over 2 is the same as 2 pi over 4. That might help us with counting a little bit. Okay? All right, let's start graphing. Count out those x values. Y-axis, x-axis. Okay, so we're starting pi over 2 to the right, which is 2 pi over 4. Okay, so here's pi over 2. Think it's 2 pi over 4. So if I add 3 pi over 4, now I'm at 5 pi over 4. Add another 3 pi over 4, I'm at 8 pi over 4, better known as 2 pi. So a 0 is going to be there, asymptote right here. I need 2 more x values, hang tight. So we've got 2 pi over 4, that was 8 pi over 4. Add another step, another 3 pi over 4, that's 11 pi over 4. Add another 3 pi over 4, now we're at 14 pi over 4, but that's 7 pi over 2. Okay, how are our fractions doing? If you still need to do them off to the side, that's okay, but train your brain, okay? It's a muscle, just like any other muscle on your body. Put it to work. Okay, good. We got our 2 asymptotes. We got 2 pi 0. I need 2 more points. And remember, there's a vertical stretch of 4. So I'm going to label my y-axis. Here's 4. Here's -4. And now I'm going to plot the other 2 points. And then once you make it this far, it's not so bad, you know? And there's our graph. Wow, so nice. Came together. Okay, let's write out the domain. So the domain is going to be all x's such that x cannot equal pi over 2, right? That's where our first asymptote is. That's not negative. Plus, how long does it take to repeat? What is the period? 3 pi. Okay, so pi over 2 plus 3 pi k. All right, k is an integer for those of you who don't like the abbreviation, just this once. Look how much writing that is. No wonder I don't like it. And then the range is -infinity to infinity. Okay, hooray! So you should be set for tangent and cotangent. The only other mean thing they could do to you is like throw in a vertical shift or something like that, but don't fret, you can handle it. Okay, now we're going to look at secant. The way you graph secant is you first graph lightly, like in another color, with dashed lines, the graph of cosine, okay? And then everywhere the graph of cosine is equal to 0, you're going to put a vertical asymptote for secant, right? Because secant's graph is 1 divided by cosine. So wherever cosine 0, secant's going to have an asymptote. And then they share all the max and min values. So I'll show you all the maxes on the cosine graph, secant will also include, and then all the mins on the cosine graph, secant will also share. Because those are the points where cosine is 1 and -1. And so secant will also be equal to 1 and -1 there, because the reciprocal of both those numbers are themselves. All right, here we go. So find the period, the phase shift, and sketch the graph of the equation. If you have my old unedited notes, it might say amplitude, and shame, there's no amplitude for these graphs, okay? All right, so we're gonna graph 1/4 secant x. First, I want you to think of just graphing 1/4 cosine of x, okay? So the period is just plain old 2 pi, and the step is gonna be pi over 2. Now the cosine's graph, the amplitude is going to be 1/4, okay? But for secant, there is no amplitude. So here we go, y-axis, x-axis, and we have 0, then I'm going to count pi over 2, pi, 3 pi over 2, 2 pi. What does cosine's graph look like? Well, it starts up at 1. In this case, that's 1/4, and then it goes down to -1 or -1/4 here. So we go up, down, up, middle, down, middle, up. Okay, I'm going to draw cosine's graph lightly. This is the unofficial graph, right? We're not finding cosine. We're asked for secant, but we're going to use it as a guide. So remember, secant of x is equal to 1 over cosine of x. So everywhere cosine of x equals 0, we have a vertical asymptote for the graph of secant. So where are the zeros for cosine? Right here at pi over 2. So draw yourself a vertical asymptote. And then another one here at 3 pi over 2. Okay? And then like I was saying, all the points where cosine's graph originally is 1 and -1, secant's graph will share those values. So what it looks like is they share this point, this point, this point for one period. And secant's graph, if you remember from the first lesson when I showed you the computer generated one, it looks kind of like these little smashed parabolas, always going away from the x-axis. Okay, and then we only get a half a one here. If we drew more than one period, you get more cycles of these little smashed parabolas. I say they're smashed parabolas because a real parabola isn't squished between two vertical asymptotes like this. I know you guys did that video assignment where you were graphing a bunch of parabolas, finding their vertex, and their domain is all real numbers, but not here. So they look like parabolas, but they're not really. Okay? Good, good, good. So you don't have to include that portion of the graph. We just used it as a guide. I'm going to leave it there for now for you to understand. Now let's write out the domain and range. So the domain is going to be all x's such that x cannot equal. Well, notice here we've got an asymptote at pi over 2, but then we have another one at 3 pi over 2. For secant and cosecant's graph, the asymptotes repeat a little more often. They repeat every half a period. So remember, for tangent and cotangent, they repeat every full period. For secant and cosecant, it's every half a period. So in this case, since the period was 2 pi, they repeat every pi. So I'm going to say x cannot be pi over 2 plus pi times k, where k is an integer. And then the range, you have to be oh so careful. So the range is going to be given by two separate intervals because we have all of these portions of the graph that go from -infinity up to -1/4. And we're going to include -1/4. And then we have the other portion of the graph that goes from +1/4. So you put union +1/4 to +infinity. So you have the upper half of the graph, the lower half in the graph. You have to write it from smallest to largest. And it's always going to be two separate intervals like that you join together for secant and cosecant. Okay? Good. Don't worry, we'll practice some more and then you're easily going to become a professional. Okay, next one. Y equals, wow, they're just throwing everything at us, -3 secant 1/3 x plus pi over 3. Here we go. So the 3 is negative. So not only we have a vertical stretch, we also are going to reflect the graph, right? It flips over the x-axis. So don't forget to do that. Now let's find the new period. So the period is equal to 2 pi divided by b. What's b? It's 1/3. So 2 pi divided by 1/3, that's 2 pi times 3, so 6 pi. The period's 6 pi. What's the step? The step is always the period divided by 4. So that's 3 pi over 2. And we have a phase shift, don't we? So the phase shift is equal to c divided by b. Well, since we have plus pi over 3, remember, it's supposed to be bx minus c. So if it looks like bx plus c, it's actually bx minus -c, right? So the phase shift is negative pi over 3 divided by 1/3. So the phase shift is negative pi. What does it mean when it's negative? That you go to the left. Oh my. Okay. Here we go. So we're going to start at negative pi And then the step is 3 pi over 2. So right away I'm like, oh man, those denominators don't match. So let me think in terms of common denominators. Negative pi is negative 2 pi over 2, right? Okay, so it looks like we should scale by that. So here's negative 2 pi over 2, or negative pi. Okay, so that's negative 2 pi over 2. And I'm going to count 3 pi over 2 for each step. I'll do the work over here. So we have negative 2 pi over 2 plus 3 pi over 2 gives me 1 pi over 2. Okay, then you take pi over 2, add another step, add another 3 pi over 2. That's 4 pi over 2. Am I going to write that? No way. I'm going to write 2 pi. Then I take 4 pi over 2, add another 3 pi over 2. That's 7 pi over 2. 1, 2, 3, 7 pi over 2. I got 4. One more. 7 pi over 2 plus another step, 3 pi over 2. That's 10 pi over 2. Is that what I should put? No, no, no. You're going to put 5 pi. Okay. But all of the tick marks represent a pi over 2. Okay, then we got to go to 3 and negative 3. All right, and then we're going to start off plotting points for cosine. So remember, normally cosine would start up at the top. However, we've got that negative, so we're reflecting over the x-axis, so we start down here. Then we do the next x value that we labeled. That's where 0 is going to happen. Students love to put it in the wrong spot. You know what they like to do? This is always tricky. They like to put it right here. But that was not one of our 5 key points that we labeled, okay? So skip over it. I know it's hard, but fight the urge. Pi over 2, 0. Then 2 pi, we go up, back to 0, down. So here's the cosine graph. You can just draw secant from here. I'm going to tell you the truth. I do. I just look at where the zeros are and I draw my vertical asymptotes. So I just go, here's a vertical asymptote. Here's another one. And then this part's going to go away. And then this part, they always go away from the x-axis, okay? Away, away, away. But if that worries you too much, you can always just draw this in. But make sure you understand that's not part of your final answer. So do it dashed or in a separate color or something, okay? So you don't need the full graph, you just need the points. Now let's list out the domain. The domain is going to be all x's such that x does not equal. What's the first equation for the asymptote that's not negative? Right here at pi over 2. So x cannot be pi over 2 plus, how long does it take to get another asymptote? Remember, it's half the period. If you forget, you've got a graph to help you. You go like this. There's one at pi over 2, and then there's another one at 7 pi over 2. How far apart are they? 7 pi over 2 minus pi over 2. That's 6 pi over 2. Oh, they must repeat every 3 pi. Okay. You see that? So if you forget the rule, have no fear. You have your graph. Just write down what makes sense based off the graph. And then the range is going to go from negative infinity to negative 3. Include it. It's a solid point on the graph. Union 3 to infinity. All right, good job. We've got one more. It's cosecant. It's no big deal because you basically did the same thing that we did for secant. It's just you start off with sine instead, you know? Okay, here we go. So start off by graphing sine. The asymptotes for cosecant come from wherever the zeros are on the sine graph. Bada bing, bada boom. Again, there's no amplitude for cosecant. So if that's in your notes, cross it out. If someone asks you for amplitude, tell them I'm not allowed to give it. There is not one. Okay, so find the period, phase shift, and sketch the graph. First thing I notice, we have actually a vertical compression of 1/2. Period, same as standard, just 2 pi. So the step is always the period over 4. So it's going to be pi over 2. There's no phase shift. Nothing's being added or subtracted to x. So time to get rolling. This one's not going to be bad. Y-axis, x-axis, and let's start labeling our x values. So we got 0, pi over 2, pi, 3 pi over 2, 2 pi. And then remember, we only go up to 1/4. No, 1/2, excuse me. I think 1/4 was the other problem. And negative 1/2. Okay, so let's graph sine first. So sine starts at 0, 0, 0, up, back to 0, down, back to 0. Here's sine. Now the only difference is everywhere sine is 0, cosecant's going to have an asymptote. So it has an asymptote right here at the y-axis, and then another one here, and then another one here. We've got 3 asymptotes. How fancy. And then again, yes, it looks like smashed parabolas. This one comes out a little bit more visually pleasing because you get 2 nice complete pieces, where on secant you have the 1 in the middle and then you got a 1/2 on each side. So I've always been a little partial towards cosecant because it just looks so nice. But no, secant's got its pluses too. It's a little interesting to look at. So domain. Domain is going to be all x's such that x cannot equal. Well, notice the first asymptote's at 0. The next one's at pi. The next one's at 2 pi. So you could write x does not equal, remember, 0 plus pi k, but you don't put 0 plus anything. You just write that means x can't equal pi k. It repeats every 1/2 a period. 1/2 of 2 pi is pi. Or just look at your graph and see they're all spaced apart by pi. So x cannot equal pi k. K is an integer. What about the range? Negative infinity to negative 1/2. Union, upper half is 1/2 to positive infinity. Very nice. How are you feeling? Shall we do one more? What's left? Oh, it's pleasant. Let's do it. Okay. So we have 4 cosecant 1/2 x minus pi over 4. So we've got a vertical stretch by 4. The period equals 2 pi divided by b, which is 1/2. So 2 pi times 1/2, that's 4 pi. The step is the period divided by 4, so that's just pi. And then we do have a phase shift here. The phase shift is going to be pi over 4 divided by 1/2. So that's pi over 4 times 2 over 1. So 2 pi over 4, that's pi over 2 to the right. That's it. Okay, let's start labeling. So I'm going to start with pi over 2, and then I'm going to keep adding this step, which is pi. If you want to think of that, that's 2 pi over 2, right? The step. Here we go. Y-axis, x-axis. So we start at pi over 2 to the right. Okay. Now I'm going to add 2 pi over 2. That's the step. So if I add 2 pi over 2, that's 3 pi over 2. Add another 2 pi over 2, 5 pi over 2. Add another 2 pi over 2, 7 pi over 2, and then 9 pi over 2. Is that all of them? Yes. Look, if you're nervous, oh my goodness, I don't know if I did my fractions right. You started at pi over 2, you stopped at 9 pi over 2. Subtract them. 9 pi over 2 minus pi over 2, 8 pi over 2. Is that 1 period? Is that 4 pi? It sure is. See? So you can check yourself along the way. Vertical stretch by 4. So we're going to say this is 4, this is negative 4, and then remember we're graphing cosecant. So I'm going to start off using sine as a guide. Okay, so sine starts at 0, then it goes up, then back to 0, down, back to 0. You can fill in the rest of the graph of sine. I don't usually, because then it gets messy. I don't like it messy. So here, oops, here's your asymptote. Here's your next asymptote. Everywhere the graph has a 0, you draw an asymptote. And then the rest of it are smashed parabolas going away from the x-axis. This was not nice. Make sure your graph looks nice. Have some pride. Put some arrows. Do it nicely. Lovely. Okay, domain and range time. Domain is going to be all x's such that x cannot equal. Where do you see the first non-negative asymptote? It's at pi over 2 plus, how long till there's another asymptote? Half the period, or you can just count how far apart are each of them. They're 2 pi apart, plus 2 pi k. K is an integer. And then what about the range? It's negative infinity to negative 4, that's the bottom portion, union 4 to infinity. All right, that's it. Bravo. Give yourself a pat on the back. These will take practice, but they get repetitive after a while. Once you get bored with yourself, you know you understand what's going on. Okay, that's definitely going to be one of the hardest sections. And then moving on, you should enjoy the next one. You're just going to find an equation from the graph, so more relaxing. All right, stay tuned. Good job, you guys.